Hello, chemistry students. Tonight we are going to do a little final review for our seniors. Seniors have their final on Thursday, so hopefully this will help if you watch this video. So for the final, I gave you a review sheet, or if you didn't get it, it's on Edmodo. And there's just 5 questions. They're long. It's a 4-page test. And what I'm doing is there's not any multiple choice, there's not any true and false, there's not any vocabulary. All it is showing me that you understand these concepts, and it's not every concept on the sheet. It's just a couple. So I'm going to kind of go through your review sheet with you and just do some of the important ones. Okay. So electron dot structure is the first thing on your list. This was back in chapter 8. Where we learned the electron dot structure and also that off-bar diagram and electron configuration went along with this. And so all we're looking at with any of these, the off-bar diagram and the electron configuration, is we're just looking at the electrons in a given element. Okay, so let's do an example here. Say let's use the element of sodium. Okay, if we're going to use the electron dot structure of this, we're going to be looking at the valence electrons. Okay, so the valence electron is equal to the group number, okay, on the periodic table. So group A works for this. So if you look back at the periodic table, sodium is in group 1A, and so we would know that since it has just one, it would be just one electron. Okay, so if we maybe were to do chlorine, we look at the periodic table and it's in 7A, so we know that it has 7 valence electrons. Okay, and so what this does for us is this shows us why sodium and chlorine would combine. Okay, this electron dot structure can be used for either covalent or ionic bonding. In this case, we could see that these two are going to ionically bond. First, because we know this is from the left side of the table and this is from the right, but also this is in need of one electron and this has an extra one. So we know this is going to be a give and take relationship, which is going to be ionic bonding. And so we're going to get a structure that is covalently bonded, ionically bonded from charges. So now this has a negative charge and this has a positive overall charge because of the loss of electron and the gain of electron. Okay. Off-bar diagram and the electron configuration, they deal more with the total electrons. So electron configuration of sodium would be that 1s2, 2s2, just using the periodic table. So this is period 1, block S, there's 2 elements. Period 2, block S, there's 2 elements. Then we move across and there would be 2p, and there's 6 elements over there, so we'd be using the 6. Then when we drop down to the 3rd period, S block, there'd be 1 electron. So this would be here the electron configuration of sodium. Okay, and we can also draw the off-bar diagram. That is just where we draw squares for these. So 1s, 2s, 2p, 3s, and so the s's would just get 1 block because 2 electrons go in each box. So the p, since 6 electrons go in that box, we would get 3 boxes. And so we know they fill up and down, and all the ups go first in multiple boxes, and then it fills in the down boxes, and then 1 up. And that's because sodium, we know, has 11 electrons. So if we counted these arrows, there would be 11 here. And so that would be an example of an electron off-bar diagram. And this is the example of the electron configuration. Okay. The next thing is that formation of ionic compounds from chapter 8. And this is referring to that positive and negative charge. So when you look at something like oxygen, it's in group 6A, so it has 6 valence electrons, which is lacking 2. Therefore, it has an overall charge of -2 because when it gains its 2 electrons, it's going to have 2 more electrons than it does protons, therefore giving it a -2 charge. So if you bond it with something like lithium, for instance, lithium has an extra electron. So when it loses that electron, it's going to become positively charged, +1. Now there's 2 ways that you can figure out what the formula is going to be during the formation of an ionic compound. You can take the charges, not the group number, take the charges, the -2 and the +1, and you can crisscross them. That's a crisscross method. Okay. So in this case, this would be Li2O. Okay. Or you could draw out the electron electron dot structure. So lithium's in group 1, so it has 1 electron. Oxygen's in group 6A, so it has 6 valence electrons. And you can see them moving over there. You'd need 2 lithium to make oxygen happy. And we'd see that there's 2 lithium and 1 oxygen, making lithium and oxygen bonding together, this being their formula. Okay. Now there is going to be a table or a section on naming acids. Okay. And so naming has to do with, first of all, figuring out if it's ionic or covalent. Okay. So ionic things, they're going to be from opposite sides of the periodic table. It's a metal and a nonmetal. And if you ever see a polyatomic ion involved, or if it's something from the D block, something from D block. So anything from the D block is going to require an oxidation number, which means that you have to write it out. We'll do an example of one of those in just a second. Okay. Covalent bonding is going to be all in the P block. So both elements are from the P block. That's covalent. And it's 2 nonmetals. And acids. Acids are covalently bonded. Okay. So there's some of the things that we can look at. So if I give you a couple examples, like we have maybe lithium phosphate, and we have maybe dicarbon hexachloride, and maybe we have something like TiBr2, right, a couple formulas here, HCl, and then we have one that's maybe chloric acid. Okay, so what we need to do is first identify what it is, ionic or covalent. So I look here, lithium's on the left side of the periodic table, and I have a polyatomic ion. So right off the bat, I know that this is going to be an ionic bond. Okay, so I'll just write an I for ionic. So with ionic, we don't have to use any prefixes, so we would just go ahead and write Li. And phosphate's a polyatomic ion. Anytime you see that ATE at the end, you know it's a polyatomic ion. Lithium's charge is a +1. Phosphate, you can use your chart, you'd see it's a -3. So if we crisscross this, lithium's going to have, there's going to be 3 lithium, and then phosphate is PO4. Okay. Dicarbon hexachloride, since carbon and chlorine are both in the P block, I know this is a covalent bond. Okay. And so I'm going to have 2 carbons. We have that prefix di, 2 carbons, and hexa means 6, so it's going to be Cl6. Okay, this one is the formula, and we're going to write out the name. So Ti is titanium. And here I know titanium's from the D block, and so I know it's going to need an oxidation number, and it's ionic. And so titanium, we're going to have to put its charge there. Since bromine is a negative charge, -1 charge, titanium must be a +2 charge since there's 2 bromines. So I'm going to go ahead and put 2 in there and then write out bromide. Okay, so titanium bromide. Notice we didn't put dibromide because it's ionic. Okay, if it's covalent, it's the only time we use these. Okay. The next one, we see the H in front, so we automatically know it's an acid. Acids are covalent, so we would put a C here. Okay. And since there's no oxygen, it's a binary acid. Binary acids have hydro on the front. So I know my first thing I'd have to do is write hydro. That's chlorine, so I'd write chloric acid. Okay. And all of them that are binary have the ic acid in them. Okay, so it's hydro, whatever that root is from the second atom, and then acid. Now this one, since there is not a hydro, first of all I know it's covalent because it's an acid. Since there is no hydro, then I am no, it's a polyatomic ion because it has oxygen in it. So I still have an H in front. So my polyatomic ion ic is 8. Okay, where OUS is ite, so since it's ic, I know it's 8, so it must be chloric acid. So I know chloric is a chlorate is a -1, so there's only 1 hydrogen, and then I know it's ClO3, perchlorate is 4, so it's HClO. So that's just the chlorate ion and a hydrogen. Okay, so hopefully that helps you remember or refreshes your naming. Okay, now we're going to talk about a little bit more covalent and the structures. There will be a section on your test where you have to draw some covalent bonds. Covalent bonds are easy to name because you just put the prefixes in front of them, but they're hard to draw, okay, because they all have very particular structures, unlike the ionic bonding. So we're just going to do a couple examples of the calculation. Okay, so let's do something like CH4. Okay, when we see any of these, we figure out the number of atoms. Okay, and there was that sheet, the molecular structure sheet that has the linear and the bent structure, tetrahedral. So you probably need to get this out and review it. The sheet had trigonal, planar. I'm not going to go over all of these. Okay, you can just look at your sheet. Octahedral. Whoops. Octahedral. Trigonal bipyramidal. Oops. Okay. So I'll let you guys look into that a little bit with your sheet, but by looking at the number of atoms, we can kind of tell what structure it's going to be by memorizing these. So if you haven't done these in a while, get those out. But I'm going to refresh you on how to do the calculation. So here we have 1 carbon atom. Draw an X in a line. Carbon atom goes on bottom. You look at the valence electrons. That's the big thing here, valence electrons. So carbon has 4 valence electrons. Whoops. I'm used to doing the mole here. Too many lines. Okay. And then hydrogen, since there are 4 of them, we would plus the next element. So we put 4 hydrogen atoms. Then you would put hydrogen atoms on bottom. 1 valence electron, so you would have 4. 1 times 4 is 4, plus 4 times 1 is 4, would equal 8 total pairs. And so then you would divide that by 2 always. And so you would need 4 shared pairs. Okay, so I know that this would be tetrahedral because it's the only one with 5 total atoms. You have 4 hydrogen and 1 carbon. So carbon would be my central atom. because